Okay, hi everyone, welcome back to this video series on Introduction to Firewalls. Deploying a three-pronged firewall. Now that we've discussed some of the design issues with three-pronged firewalls, take a look at three actual deployment scenarios so you can see how firewall rules are affected by a three-pronged firewall. The three examples that we look at are a point-to-point tunneling protocol server using radius authentication, a layer 2 tunneling protocol server using radius authentication, a web server that connects to an SQL backend server for storage of data. Deploying a tunnel solution using PPTP. Deploying a tunneling solution in which your network uses a three-pronged firewall allows you to perform the actual remote access authentication at the private network rather than in the DMZ. Figure 11.5 shows the network configuration that we use for this example. In this scenario, the key servers that are protected by the firewall and the tunnel server located in the DMZ at IP address 192.168.223.22 and the radius server located in the private network at IP address 192.168.222.3. In addition, only connected tunnel clients are allowed to access resources on the 192.168.222.0/24 network. All other private network access will be blocked at the firewall. The first step in this deployment is to define a static address mapping for the tunnel server located in the DMZ. As figure 11.5 shows, the firewall is assigned IP address 23.16.16.5. A static address mapping must be defined to allow only PPTP connections to be redirected to the tunnel server located in the DMZ as shown in table 11.2. The static address mapping ensures that all data sent to TCP port 1723 on the external interface of the firewall is redirected to the tunnel server's TCP port 1723, and that all generic routing encapsulation GRE packets protocol ID 47 are also routed to the tunnel server at IP address 192.168.223.22. Table 11.3 shows the firewall rules that must be implemented at the firewall to ensure that only tunnel-related traffic is allowed to enter and exit the DMZ. These firewall rules assume that all tunnel clients will be assigned IP addresses in the range 192.168.223.128 to 192.168.223.225, 192.168.223.128/25. Deploying a tunnel solution using L2TP. L2TP tunneling doesn't have a built-in encryption algorithm. The IPsec ESP tunnel is used to encrypt the L2TP packets as they are transmitted from the tunnel client to the tunnel server. The firewall rules that you implement will depend on whether the tunnel clients and tunnel server support NAT-T draft. Firewall rules when NAT-T is not supported. If the tunnel client and server don't support NAT-T, then public network addressing must be used as shown in figure 11.16. As figure 11.6 As figure 11.6 shows, the DMZ uses public network addressing rather than private network addressing. In this example, the L2TP tunnel server is located at IP address 23.16.18.17. Because public network addressing is used in the DMZ, the firewall doesn't have to define any static address mappings for accessing the DMZ. In this case, the firewall must ensure only that its routing table knows that access to the DMZ must pass through the network interface connected to the DMZ. Table 11.4 shows the firewall rules that must be implemented to allow an L2TP tunnel client to connect to the tunnel server located in the DMZ. The table assumes that once authenticated, the tunnel clients will be assigned an IP address in the 23.16.18.128/25 address range. In the listing of firewall rules, the first two rules allow any tunnel clients to connect to the tunnel server using L2TP. You may be wondering, how do these rules allow L2TP when they are all related to IPsec and not to L2TP? An L2TP tunnel server accepts connections by listening on UDP port 1701. So for more information on the specific ports used by applications, see the appendix. IPsec firewall rules are used at the firewall because when the tunnel passes through the firewall, the data is encrypted with IPsec. You must be careful when you use IPsec, because with both these firewall rules, any protocol can be used to connect to the tunnel server as long as it is encrypted using IPsec. The first firewall rule is used by the two IPsec endpoints to negotiate a security association using the Internet Key Exchange (IKE) protocol. After the initial negotiation is completed, the security association uses either ESP, AH, or some combination to encrypt all L2TP packets as they are transmitted through the firewall. The second and third firewall rule ensures that the AH and ESP packets can be only sent to the tunnel server located in the DMZ. As with the PP example earlier, the third and fourth firewall rules allow radius to be used for both authentication and accounting functions. These rules allow only the tunnel server to use radius to communicate with the radius server on the private network. External computers are not allowed to communicate with the radius server directly. The last rule allows only the tunnel clients to connect to resources on the 192.168.222.0/24 network. If connections are attempted to resources anywhere else on the private network, the firewall blocks the connection attempts. As with the PPTP example earlier, the final rule can be replaced with a series of rules that uniquely identify each protocol and resource that's accessible to tunnel clients connecting to the L2TP tunnel server in the DMZ. Firewall rules when NAT-T is supported. If both the tunnel clients and the tunnel server support NAT-T, then the addressing scheme shown in figure 11.7 may be implemented in the DMZ. This configuration further protects the DMZ by using NAT to hide the addressing scheme implemented in the DMZ. Because NAT is performed on all traffic that enters or exits the DMZ, a static address mapping must be defined to allow only L2TP IPsec connections to be redirected to the tunnel server located in the DMZ as shown in table 11.5. So you can see here. The static address mappings ensure that all data sent to UDP port 500 NAT-T on the external interface of the firewall is redirected to the tunnel server's UDP port 500. Likewise, NAT-D traffic destined to UDP port 4500 is also redirected to the tunnel server. Static address mappings for ESD protocol ID 50 are not required because the original ESP data is encapsulated in the NAT-T packets. The NAT-T draft only supports encapsulation of ESP traffic, therefore AH is not supported in NAT-T implementations. Table 11.6 shows the firewall rules that must be implemented at the firewall to ensure that only tunnel-related traffic is allowed to enter or exit the DMZ. These firewall rules assume that all tunnel clients will be assigned IP addresses in the range 192.168.223.128 to 192.168.223.255, 192.168.223.128/25. Deploying a web server with an SQL backend. Our final example shows you how to configure access to a web server that acts as a front end to a database application. The SQL server that acts at the back end for the database application is located in the private network as shown in figure 11.18. In figure 11.8. In figure 11.8, the web server is located in the DMZ at IP address 192.168.223.13, must access an SQL backend server located in the private network at IP address 192.168.222.5. To access the web server, the firewall must allow both Hypertext Transfer Protocol HTTP and SSL Secure HTTP HTTPS to access the web server. In addition, the firewall must allow the web server to communicate with the Oracle server using TCP IP sockets. This requires connections to the Oracle server listening on TCP port 1521. This example assumes that an Oracle SQL server is acting as the database backend server accessing SQL net connections. If you use a different SQL server such as Microsoft SQL Server, read the documentation to determine the correct ports to open in order to allow access to the database server. For example, Microsoft SQL Server listens on TCP port 1433 for SQL connections. The first step is to define the static address mapping that redirects HTTP and HTTPS packets received at the firewall to the web server in the DMZ. Table 11.7 shows the static address mappings that must be deployed at the firewall to allow HTTP and HTTPS redirects to the web server. After the static address mappings are defined, the firewall rules can be configured at the firewall. Table 11.8 shows the rules that must be implemented in order to allow connections to the web server and to allow the web server to communicate with the Oracle backend database in the private network. So you can see here a DMZ hosting web database application. So the first two firewall rules allow both HTTP and HTTPS connections to the web server located in the DMZ. The last rule allows the web server to connect to the Oracle server located in the private network. This example differs from the tunneling examples because the rule actually refers to the web server making the connection. In this case, the web server is executing the SQL query or update requested by the web client. The web client doesn't have any direct access to the Oracle SQL database server, which increases security because the web pages can be coded to restrict the type of access allowed to the Oracle SQL server. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.